CloudDB, shaping your new normal.
Hello everyone, and welcome to my session on offload data processing with serverless computing. My name is Adrian, and I'm a senior cloud solutions architect at Insum. My key area of specialization is in Oracle Application Express and the Oracle Cloud Infrastructure. I am an Oracle ace, and by virtue of that, I often blog and share content with the community. If you're interested in reading about the stuff that I write, please feel free to look me up at my blog or on Twitter at Fuzzy Brain. I am also a proud book author of the book Getting Started with Oracle Cloud Free Tier. If you're new to the Oracle Cloud and wish to learn more about how you can fully make use of what Oracle is providing to us for free, please grab a copy for yourself. For some of you, you may have heard of the Apex Challenge coins. I am the person behind it. And if you're keen to celebrate any of your colleagues or friends who have helped you in any of these three areas, please do sponsor them a coin. As I mentioned, I work at Insum. I've been at Insum for about 6 years. Insum has been an Apex Center for Excellence for the last 20 years. And we specialize in Apex. We do custom application development, forms modernization, as well as SaaS extensions. And we do that through consulting, coaching, as well as staff augmentation. We are also in the business of database administration. And if you are curious as to how to move to the cloud, then talk to us, as we are also an OCI expert. We are staffed with many good professionals, and several of them are, like me, an Oracle ace. I'm happy to also share that Insum in recent days had announced that we were acquired and are now part of the Talent Group based in France. For Insum, we have our head office in Montreal, Canada, and we also have offices in the US as well as in Peru. And more recently, I'm excited to say that we are looking to start our office in Singapore so that we can also service the good people in ASEAN and Greater Asia. And if there are opportunities for us to work with you, please feel free to reach out to either Graham or myself. So, what are our key objectives for this session? The first is to basically explain what serverless computing is. In the process, I would also like to share some ideas, and that may give you some clues as to what type of use cases you can apply serverless computing in solving the problems that you face. And a large bulk of this session is dedicated to sharing knowledge I have about how we can actually work with Oracle Cloud Functions. But before I begin, I just wanted to share how I actually embarked on this journey to begin with. If you've been working with Oracle databases for a long time and have had the chance to work on applications which require multimedia processing, then you would be familiar with the Oracle Multimedia, or more affectionately known as OMM. Unfortunately, Oracle Multimedia has been deprecated for quite a while, and it is fully desupported in version 19C of the database. So you will not find any of the PL SQL packages that will allow you to do the following. So this is an old diagram from a previous version, and it kind of explains the role that OMM actually plays in the database. So as its name implies, it is involved in processing multimedia formats, so be it images, videos, or audios. And particularly for the medical domain, OMM has also been used for processing DICOM files. So with OMM out of the picture, what are our alternatives? Perhaps this is something familiar to all of us. So one way is we could, for example, install ImageMagick, which you can find in most Linux installations, and perhaps write a bash script and run it as a database scheduled job. But that has a problem on its own. Not many DBAs that I know would be happy about installing applications that are not related to the database on a database server. So getting past this hurdle may be a challenge for some of us. And there is also a potential impact on performance if, for example, this is a runaway job or process. So if we're not going to run it on the database server, where else could we put it? These days, we can think about wrapping the applications using a REST API. So you could, for example, have a library, a Node.js library, for example, to do the image processing based on input parameters of a web request. And you would expose that with a framework somewhat like Express.js or Restify. However, like in this little image that I'm sharing, it often is a complex task because we have many things to consider when we attempt to expose a REST service. The concerns like security, maintaining the infrastructure that runs the web service, and many, many other things. So more often than not, we end up with a product that is not really polished. We might actually consider consuming an externally managed REST API. However, there are considerations that we have to take into account when using third-party resources, such as cost. And in some cases, we have to worry about data residency. It may not always be possible to take an image, a photo perhaps taken of someone, and sending it over to a third party, which you will not have any control of how they decide to process that file in order for you to do a simple task such as thumbnail generations. So perhaps the solution lies somewhere in between, and that would be with serverless. But before I move on to serverless, I just wanted to also mention that in future, we would have the MLE, or the multi-language engine, that will come with the database. And at that point, there would be possibilities such as running Python scripts and JavaScripts on the database. And these could very well play a part in doing many of these tasks that we require. But that is much further down the road. So what is serverless computing? Sometimes you may more affectionately hear them as functions as a service, or FaaS. And as its name implies, it is really hosting a functions as a service. So this service is fully managed. You will not have to worry about things like infrastructure, how to stand up or shut down services. These are all taken care of by the vendor. It typically involves just performing one and only one function or role. It is elastic, so at any point in time, if your application requires a greater amount of processing, the infrastructure will be automatically scaled in order to achieve the performance that you require. It is also pay-per-use, so unlike traditional services such as a virtual machine, you only pay for the time that the function actually runs and nothing more. In some cases, you only bill per second. And if the service is not consumed a lot, that's quite a bit of savings. So where does function lies amongst all the other possible solutions? So on this chart, on the left, we have bare metal machines, virtual machines, container, and functions. So as we move across the spectrum, we see that there is decreasing areas of concern. So if we were to host our REST APIs on the bare metal servers, we have to think about acquiring the necessary hardware, installing the operating system, and then installing and configuring the software for running the service. These days, many of our cloud vendors actually provide virtual machines. Virtual machines run on top of a hypervisor, and hence you don't really have to worry so much about the underlying infrastructure itself or the host operating system. Your code and any application that you need to run within a self-contained virtual machine. Containers take it a step further, where we don't even have to worry about the host operating system. And function, of course, is yet another subunit of computing. With decreasing amount of areas of concern, it leaves us the ability to focus on our goals. So as we progress towards running just functions, we can fully concentrate on implementing the business logic and not have to worry about all the nitty-gritty details of hosting that service. But that also means that you have lesser amount of control, which perhaps isn't so bad, since it would have probably increased the ability for us to deploy our services as soon as possible. One comparison that I did not put on this chart is cost, because cost really depends. If you had, for example, a function that is called millions and millions of times per minute, then it doesn't really make sense at that point to use functions, and you might actually save more money by perhaps hosting it within a container. Nearly all the major cloud providers provide serverless computing in some form or fashion. Perhaps the most well-known one would be AWS Lambda. And for Oracle, it's called Oracle Cloud Functions. And it will be the key area that we're going to focus on. Oracle Cloud Functions is one of several cloud-native services that the OCI provides. Some of them interact with functions, for example, the container registry, which stores Docker images. And functions can also be triggered by things such as notifications, events, or even through an API gateway. And it can act against streams and even the autonomous database. So what are the key use cases of Oracle Cloud Functions? One of the primary use of functions is really to manage the OCI resources itself. You could, for example, think about auto-starting your always free autonomous database when it shuts down after 7 days of inactivity. It is also used when dealing with really thin clients, right, such as IoT devices, which do not typically have a lot of computing powers. For those of you who have been following the in-person events over the last 5 years, I believe, Oracle have been giving out this code card, which is a single chip device which has low amounts of processing and memory, enough to maybe do things like manage your display, but not enough to do computing, heavy lifting of compute jobs. And because it is able to also interact with the internet, you can actually deliver some of these computing workloads through an Oracle functions. For myself, I had the experience of working on an Alexa skill. It is a simple skill for just telling me about the current space weather conditions. But in order to implement the backend logic to, for example, pull the data from NOAA services, I rely on AWS Lambda to do all that. So working with the web services, external web services itself is done not on the device, but on the Lambda services. One very important use that I've seen customers using has to do with data processing itself. ETL on IoT data, for example. Perhaps there's some special encryption that needs to be decrypted on the server side, and we couldn't do this with PL SQL. So what the client actually would do is to decrypt the software and write to the database using an Oracle function. And with this implementation, they're actually able to handle the massive stream of IoT data in a timely fashion. If you have followed my earlier session on building intelligent Apex application, you would also see that there is a need to, for example, run some computer vision framework, for example, performing OCR on documents. And in this presentation, I would actually like to focus on a simple use case, and that's to generate thumbnails. So deeper into what Oracle Cloud Functions is, when the OCI started on its journey towards serverless computing, what Oracle did really was to acquire an open source project called FN Project. FN Project is unique. It focuses on using Docker containers by means of executing the code. It is also compatible with cloud events, so we'll cover cloud events later on in this session. And it comes with a developer kit or FTK, and it supports some of the major programming languages that we have, for example, like Java, Python, Ruby, Node.js, and Go. There is also community support for C#. So if that is a language that you're familiar with, there is an alternative. But for the official FTKs, Oracle supports these following versions, and the one in bold is the default and most recent version. So let's get started with Oracle functions. So the first thing we need to kind of know is how to kind of prepare our OCI environment. You'll need some knowledge about things like compartments. So compartments in OCI is really a logical way of grouping things. you need to have a virtual cloud network with at least one subnet, preferably a private subnet, which is what I typically use. And you also need to be familiar with obtaining a unique identifier known as the Oracle Cloud Identifier, or OCID for short. OCI also focuses a lot on security, and a lot of how security is managed is through policies, and policies have statements that would define privileges. As with all good security best practices, privileges are assigned to groups typically, and then you would assign users to those groups in order to perform actions that are required. To work with functions, you will definitely need tools such as the OCI CLI, as well as the function CLI, or FN CLI for short. If you're familiar with the OCI Cloud Shell, it does come with the latest versions of the software pre-installed. The downside is that you typically only have about 5 gigs of storage, and maybe you want to work a little bit more conveniently of, for example, on your local machine, and you can do that. I will, in my demo, actually show you how you could even run something like Jupyter Lab and store your files on a remote compute. And for security, when you interact with OCI, you will actually need things like an API keys, and we'll walk through that as well. So what I'm going to show you now is a notebook with several steps to perform these 9 key things that you need to do when working with the function. And if you want to access the code, you can simply go to this URL. So the very first thing you want to do is to install the OCI CLI. This gives you access to pretty interesting functions and I won't repeat the installation process as I've already ran it through once. I'll, however, just kind of run this to make sure that it's installed correctly. The FN CLI, likewise, you can use a single bash command to run, and it's pretty fast. So I just wanted to make sure that I have the most up-to-date version. That's currently 0.6.11, and just make sure that it's running. I see that I have the same version, which is good. So the next thing here, what I have listed are a bunch of things that you kind of need to be prepared for. So first, you need to have a compartment ready to kind of store all your different objects that you're going to use. I pre-created a VCN using the wizard, which will create for you one public and one private subnet. And I'll actually use the private subnet for hosting my applications. What you want to do is also create an IAM group. IAM is short for Identity and Access Management. And once you have that group, you want to create a policy at the tenancy level. For some of you, you may not have access to the tenancy itself, so please speak with your OCI administrator and help them, get them to help you kind of put in these policies that you'll need. There are a couple of them. So one thing we have to realize with functions is that it will create Docker images, and it has to use the OCI container registry, and that's what the very first statement lets you do. And you have other things like using the virtual network, because you need to basically assign the application to the subnet. And of course, you need to have the ability to create, update, and maybe even delete these functions. So once you have these in place, next thing you would do is to create a user which you will use for performing many of the steps that we're going to go through. And you have to add this user to that group, and that way you would enjoy all these privileges. So one key thing about once you have your user, you need to actually set up your API keys, and there are several ways to do it. The simplest approach would be to use the OCI itself, and here you can actually just add a key and it will generate the API key. But you will have to download the private key to begin. Once it's created, you actually be presented with information that you need to put in your .oci config file. So what you can do really is to just copy out this, put it in that file, and perhaps change the profile name. And also you have to update the key file parameter to reference where it's stored. The private key is actually stored on your workstation. So once that's done, the next thing we'll want to kind of do is to set up a bash environment file, and that would make the remaining steps a lot easier. And in that file, it will ask for you to put the OCI CLI profile, and that's the profile name that I was referring to earlier on. Before we look at the template though, just the next point here, it's about generating an auth token. This is required to log into the OCI container registry. And in order to do that, you'll also have to go back to the OCI console, and under auth token, you will simply have to click this, give it a name, and then click generate. Just bear in mind that once it's generated, this token is only visible once. So make sure you copy it and put it in a safe place. So back to the template. So in this template, which you can get from the code repository, you need first of all to put the OCI CLI profile name and fill in some of these other information, which I will not go into detail at this point. But there'll be kind of guides here. So if you want to, for example, find region ID and key, they are found in this document here. The IAM user, of course, is depending on what you create. And in order to get the OSITs, you would have to, for example, go to, in the case of compartments, and this is the compartment I'm going to use. Just hit the copy here and copy that value into the file over here. And you should be good to go. So once you have this file, you can load it up. And just to make sure that everything is running in order, we can just do a quick grab of the namespace. And that's it. That's all you actually need to do right now to set up for functions. The next thing, though, that we kind of want to prep for the remaining part of the demonstration is to set up the Oracle storage buckets. So I'm going to do thumbnail generation. So the user would upload their photos to a bucket called photos, and the functions is going to generate a thumbnail size of the image and place them in another bucket called thumbnails. So we'll have to make sure that this photos also emits those cloud events that we'll describe later on, and that would trigger the functions. And in order to work with the object storage, I'm actually going to use this thing called resource principles. And to do that, I have to create a dynamic group, and it's of resource type fn function, and it will include any functions within the compartment that I specify whenever I OSIT. Then next, I have to create another policy that governs how this group here is going to actually access the buckets and what it can do. So this allows the members of the resource principals to be able to read all the buckets, so list the buckets, and also manage objects that are in the same compartment, but only if their bucket names are either photos or thumbnails. So if any of this is unclear, I did write an article about how to use the object storage along with your Apex application, and it does walk through some of these steps as well. Next, on to the setting up functions to work with your setup. So functions does have this concept called context, and you need to kind of set this up before you get going. And a lot of it is stored. So basically, contexts are all stored as configuration files within this .fn/context directory. And it will require these profiles, which this script over here will kind of help you get started. So all I have to do is just run this. And because I've already done this before, it does show this error. So let's just make sure that I'm still set up correctly. I just run inspect context. So that's my API URL and some of the other stuff that I specify. And this here is the link to the repository that I'm going to write to. So at this point, I'm actually ready to interact with Oracle functions. So I can, for example, do fn list apps, and I can see all the different applications that I've already deployed to my tenancy. And also, in order to kind of do functions still, you need to kind of log into the container registry. So in this step, basically, we just log out of any existing connections, and then we make sure that we're logging into the repository that we want with the appropriate user and password. So onto this next step, we're going to kind of quickly create an application just to make sure that we, are successfully able to deploy. Right here, I'm going to initialize an Ftk, and I'm going to use Python as my language. So I've generated the boilerplate, and if I go inside here, you can see that it actually created a requirements.txt file, a YAML file, which is the configuration for your functions, and the actual code itself. And this is your typical functions code in Python. So with that, I actually have the basic necessity to actually create an application. So running this next CLI command will create an application with the name that I specified. And it will also specify which subnet I'm going to use using its OCI. And since I've already created this application before, and that's why we're seeing this error, which is fine, I'm actually going to deploy this application, which really has only one job, and it's actually to say hello. So here we see it going through the process of creating a Docker image, and then it would push this image to the container registry on the OCI. And when it's done, it will update the function that we created. So here it says that it's been successfully deployed. And if we were to go back to the OCI console, and we list all the applications that we have, we can look for the thumbnail generation demo function, which is over here, version 0.0.2. And just to make sure that it works, we can invoke this with the CLI itself. So it does take a while, because what happens when you, and we'll walk this through again later on, you're actually invoking a function for the first time. So it does take a while to kind of create that container and return you the results. And there we go. Hello world. So as a developer, the other thing that we kind of like to do, I'm just going to go back to my slides, is to be able to debug our code. So to do that, what we like to do actually is to enable logging, and OCI logging it's a managed service. You don't actually have to do anything to get it going, except to make sure that again we have the necessary allow access to these components. So going back here, if we go to our functions, you actually see on the left that there's this thing called logs. So you can click on that. And typically this is disabled. Since I have some running applications at the moment, what you can do is just click enable. And if you were to look at the logs, you'll see that it's running, it's logging steps in your code itself. So if I go back to the code, in order to do your logging, it's really simple. Just kind of import logging. So this is for Python. I'm pretty sure there are also libraries for your Node.js and other frameworks. And really, it's just using the logging function in order to write stuff. So that here, this line that says get logger.info inside Python hello function. So make sure you have lots of these during development so that you can kind of step through and know what's going on and help you troubleshoot. So as I mentioned, when you're done writing your code, so the first thing is you need to implement the Ftk handler. And then when you invoke it, when it gets invoked, you need to pass the inputs, any other metadata that's passed along to the functions. And with that, you would use that to execute your business logic. And I'll kind of show this how you do it with events and make use of the information you get from events and then to process the images in the buckets. And finally, once you're done, just remember to write a response and exit. So when your code's ready, you would have to do a command called fn deploy, and you specify the application. And what that does really is I kind of stepped through earlier on, it would create a Docker image. And that Docker image, once it's prepared, will be published to the container registry. And then after that, it will be registered with the functions. And when something invokes this function, if you remember that there's actually a pause, that's functions trying to create a Docker container, and it will run. But after some times or some idle period, it will actually destroy the container. So if let's say you don't have any request for a substantial amount of time, the next time it actually gets invoked, it's actually going to take a longer time to start, which is perfectly normal. So let's go into the code again to do the thumbnail generation. So I've already prepared a whole bunch of sample code here. So if you run this, okay, so I've already done this previously. Actually, let me try repeating it once more. So here we go. We have the functions now. It should be updated. No, it's not. Okay, here we go. So file's been refreshed. So I talked about earlier the functions handler. So this is what it does. I do have a couple of things that it logs. And again, remember I mentioned about resource principle. So that's how I get my permissions to access the profile. So by virtue of it being a functions running within the compartment demo, I'm actually inheriting those rights, and I'll be able to obtain an object storage client, and that allows me to then, for example, get the objects that I need. And remember, I also said that we have to process the metadata that's coming in. So this actually loads the event objects itself into a variable called body. And from there, I can actually pass out information such as the bucket name that I'm trying to read from. In this case, it's actually the photos bucket. So with that, I have a couple of utility functions. So for example, getting the object from the client, and then finally generating the thumbnail itself and placing it back in the thumbnails folder. So functions also allows you to kind of set certain variables, so you don't have to rewrite your code each time you need it to change. For example, if I had to change the pixel size, I could just set a configuration, and I can actually set this all up just using the CLI itself. So on the functions code itself, you will see things like grabbing this OS environment variable and setting it for some placeholder variables that I can use throughout the application. And if I needed to change those, I can always go to the functions. Under configuration, you'll see the same variables over here, and you can just simply edit them. So if I needed to make them even smaller, I could, without recompiling the code. So with that, we can now finally redeploy this application. So I'm not going to wait for this to complete because it does take a while. What I'll kind of just quickly demonstrate to show is that I do have in my bucket photos. I can upload a image file here, and I'm just going to look for a file picture of Singapore. So just drag it over here and then upload it. We should see this file uploaded shortly. Let's try again. Okay, so the file's there. And now all we have to do is wait. So remember again, it takes a while to trigger. So here we'll just have to wait. Okay, so we'll just kind of go on while we wait for that to be processed. But again, we see the flow of the functions being deployed as an image and then finally registered against the application itself. So in order to do what I kind of showed you earlier on, is this thing called events. So as I mentioned earlier, that OCI actually implements events that's compatible with something that's open standard. It's called cloud events. In OCI, you cannot set up rules, and each rule would have an action. So the actions can be any of these at the moment, and the one that we're really focusing on is on how to trigger functions. And we're going to look at one of the events that's actually driving what I've been trying to show you earlier on. So if we come back here to the events, Under rules, we'll see that I had already created one that's to trigger the generation of thumbnails. And here, what you'll see is that I will specify the condition. So it is looking at object storage events, and object storage would actually emit 6 different types of events, including bucket creation, deletion, updates, as well as for the same 3 actions in objects. I would further say that I'm going to restrict this to only act on it or act on the event if the bucket name is photos. And down at the bottom where we have actions, I basically select functions. I pick the compartment where the functions is deployed to, select the application and the function that it has. So this one I kind of pre-created, and this one that we kind of walked through during the demo. So at this point, I'm actually going to go back into the buckets. So here's the file. And so first of all, this is the original image that I have. And now that I've generated the thumbnail, just save this. And load it. So here we have the original image and the thumbnail with a maximum either width or height of 256 pixels. So the value of doing the thumbnail generations, of course, is it does reduce the load times. For example, if you're going to load this on an Apex page. So in order to do events, you will also have to make sure that a policy has allowed you to kind of do this within the OCI console. Otherwise, you won't actually be able to see the screens that I kind of walked through earlier on. So apart from invoking functions with events, there are a few other ways. So of course, we have seen how we can do that with the function CLI. But besides these 2 approaches, we can also invoke it with the OCI REST API. Or you could even use something called API Gateway, which is one of the other cloud native services. And that really just shields you from all the complexity and just exposes it as a simple REST API, which you can call from your code. So let's talk about cost. I mean, it's nice to have all this, right? But how much exactly do we have to plan for when it, in terms of budget? So first of all, functions are actually built based on the invocations, and you get the first 2 million for free, and thereafter it's only about 20 cents for every 20 US cents for every 1 million invocations that you make. It also depends on how long the functions actually execute for. And it's calculated actually based on memory per second. So you do get to kind of manage the memory size of your functions. And the longer they run, and the more memory you have, the cost goes up. And that's actually going to cost you about $1.41 for every 100,000 gigs of memory seconds. I like to say it's free. It is free, but for those of you who are kind of familiar, there is a free tier only account, and usually in order to use certain resources such as functions, you have to upgrade that to a paid account. But that said, you could always make use of always free resources and still, do really fancy stuff with functions and pay almost no cost. But you do have to upgrade your account. So there are a couple of limits if we pay attention to. So first of all, functions, the only place you can read and write files, not read, so you can read anywhere on the functions, but you can only write to the /temp directory. There is a max size based on how large you set the memory size of your functions. There is a maximum execution time of 5 minutes. There are some hard limits, such as your payload size can only be 6 megabytes in and out. And yeah, that's probably it. But there are some other limits that, of course, you can request service limit increases if you happen to hit them. So I've said all the nice things about serverless. Let's think about, the times that maybe serverless isn't really that useful. And one of them is, the fact that if you're deploying function serverless code on any of the different cloud platforms, there is some form of locking. In the past, Lambda was, just pure JavaScript and or whatever language you're going to use. They didn't, for example, like in functions, you have a Docker file and you can, do all that kind of customizations, but you'll not necessarily be able to move them to other platforms, anytime you want. And again, looking at the cost, depending on how often these functions are actually called, the cost can actually be quite high. So just think through to make sure, figure out how many calls you're going to make, how long they're going to run, and see if Oracle Functions is really the right fit for the problem that you have. In most cases, I would say yes, but not all of them. So the take home from the session today is not everything needs to kind of run on a database, and we kind of learned that sometimes the hard way. PL SQL doesn't really support everything that we needed to do, right? So the way out really is to use functions. And once you kind of get past, writing your functions and understanding how it really works, a lot of it is repeatable, right? In the case of image processing, I could just easily translate that into a OCR application, for example, using largely the same code, except the core logic itself to, instead of generating an image, I'm really doing OCR on a document, that kind of thing. Serverless computing is not the only solution. So it's just one of many ways we can deal with problems with distributed computing. So always size up your problem, consider all options, and then make a decision, the best decision you can. But with this, I'm pretty sure you are now more confident that with functions, you can do a lot more than what you couldn't do before. And really, it's just up to your imaginations. So if you do have questions, this is a recorded session, so please contact me using any of these channels. And with that, I'd like to thank you and wish you a pleasant day.
CloudDB, shaping your new normal.